This video is the next video in trigonometry. It is looking still at section 3, which is all about sine, cos and tan. And in this particular video, we're going to look at finding a side using sine, cos and tan. So the best way to know how to do this is just by going through a few examples. So question 3.6 here says, find x corrected 3 decimal places. So when we're asked to do questions like this, what you should do straight away is you should first of all see whether it's a right angle triangle or a non-right angle triangle. And in this case it is a right angle triangle, so we can use sine, cos and tan. So the first thing you should do is write down SOHCAHTOA. Then the next thing you should do is you should label the sides. So the side that's going to be completely opposite 45 is what we call the opposite. The side that's opposite the right angle is called the hypotenuse. And the other side is called the adjacent. Now I'm just going to rub out the lines that I've drawn here. The next thing that we should do is we should highlight the sides that we have. So in this one here we have the hypotenuse, which is 40. We have the adjacent, which is the x, which we're trying to find. So we're looking for, out of the 3, sine, cos and tan, we're looking for the one that deals with the adjacent and the hypotenuse, and the one that does deal with the adjacent and the hypotenuse is cos. So the next thing you should do every single time is write out, so we have the cos of A, you can write the cos of x, you can write the cos of B, you can write the cos of x, it doesn't really matter, is equal to the adjacent over the hypotenuse, where A is the angle. So in this case we have the cos of 45 is equal to the adjacent, which is x, over the hypotenuse, which is 40. Then we multiply both sides by 40 to get 40 cos 45 is equal to x. We then just put that into our calculator, and when we put it into our calculator we're going to get an answer of 28.28427. So then this asks us to correct to 3 decimal places, so we need 3 numbers after the decimal place, so this is going to stay at 28.284, and that's equal to x. So that's this question done. Question 3.7 then says, find y correct to the nearest unit. So again, we ask ourselves the question, is it a right angle triangle or a non-right angle triangle? And we can hopefully see here that this is definitely a right angle triangle. So the first thing we should do is write down SOHCAHTOA. Then the next thing we should do is label the sides. So we have 40 here. This is going to be our opposite. Opposite the right angle is going to be our hypotenuse. And then the other one is our adjacent. So again, I'm just going to rub out the lines that I've drawn here. Now the next thing then that we have to do is kind of highlight what we want, and we have y here. We need to figure out what y is, so we have to use that, but we also have the opposite and we have the adjacent, so we're quite lucky that we just have to pick one that has a h in it. So we can pick either sine, because that has the hypotenuse in it, or we could pick cos, because that also has the hypotenuse in it. We can't pick tan, because tan doesn't include the hypotenuse, and we need to figure out. So it's completely up to you which one you pick. I might pick the sine here in this one. So it becomes the sine of A, or the sine of x, or the sine of y, or the sine of z, or whatever you want to label the angle as, of the opposite over the hypotenuse. So this becomes the sine of 40 is equal to the opposite, which is 20, over the hypotenuse, which is y. So we can multiply both sides by y, and we'll get y sine 40 is equal to 20. Then divide both sides by sine 40, and we'll get y is equal to 20 sine 40. Then you can type that into your calculator. When you type that into your calculator, you're going to get y is equal to 31.11447. So it wants it correct to the nearest unit, so this is going to be y is equal to 31. So that's this question finished. The next question then question 3.8 says find x correct to one decimal place, and it gives us a note here to be careful with your algebra at the end of this question. So again, we ask ourselves the question, is this a right angled triangle? And this definitely is a right angled triangle. Then what we have to do is label our sides. We have our angle here, so the side opposite our angle is the opposite. The side opposite the right angle is the hypotenuse, and the other side then is the adjacent. So again, I'm just going to get rid of the kind of arrows that I have there. Now, then what I have to do is I have to label the sides that we have. So in this case, we have the opposite, and we need to find the adjacent. So what we do is we write down SOHCAHTOA, and we're looking for the trigonometric value, so sine, cos or tan, which has the opposite and the adjacent, and in this case the one that does have the opposite and the adjacent is tan. So we can write that out. It'll be the tan of A. You can write X, Y, Z, A, B, C, D, any letter at all, is equal to the opposite over the adjacent. So in this case, it's going to be the tan of 30 is equal to the opposite, which is 17, over the adjacent, which is x. So we're going to multiply both sides by x, so we'll get x tan of 30 is equal to 17. We can divide both sides by tan of 30 then, and we'll get that x is equal to, when you pop that into your calculator, you'll get 29.4448. Now they want this correct to one decimal place, so that's going to be 29.4. And that's this question complete. Question 3.9 then says, an architect's view of Leinster Rugby's proposed new north stand at the RDS is given below. The architect has been informed the engineer of the following specifications. So AB is 5 meters, AC is 15 meters, angle DAB is equal to 40 degrees, and it wants us to find AD correct to 2 decimal places and DC correct to 2 decimal places. So the first thing I'm going to do is I'm going to draw that out. So we have A here. So the first thing it says is AB is 5 meters. It tells us that AC is 15 meters. That would make BC 10 meters. It tells us that the angle DAB is 40 degrees. So the first thing it wants us to find is AD. So that's part I. So we ask ourselves the question. I'm going to go over that triangle in black. So we're looking at this triangle here. The first thing we need to figure out now is it a right angle triangle? And yes, it definitely is a right angle triangle. It has the right angle symbol there as well. So then we can write down SOHCAHTOA. And in the case here, what we need to do is we need to figure out what the sides are. So across from 40 we have the opposite. Across from the right angle is the hypotenuse. And then the remaining one is the adjacent. So we need to figure out what we're going to find. So we're looking for AD. So that's the hypotenuse. So I'm going to label that as X. And we're trying to find that one. And we also have the adjacent, which is 5 meters. So we're now looking for sine, cos or tan, which one has A and H. And if you go back over to SOHCAHTOA, you can see that cos has A and H. So we write that in. So we're looking for the cos of A, and that's equal to the adjacent over the hypotenuse. So here it's going to be the cos of 40 is equal to the adjacent, which is 5, over the hypotenuse, which is x. So then we can multiply both sides by x, and we get x cos of 40 is equal to 5. And then to get x by itself, x is going to be equal to 5 over the cos of 40. Then you can just type that into your calculator. When you do type that into your calculator, you're going to get the answer of 6.5270. And it wants it corrected 2 decimal places. So we have to just have 2 decimal places. That's going to give us an answer of x is equal to 6.53. Yeah, so just to clear up the diagram a little bit, we have all the information there that we need. We just need the 40 degrees here. So what we're asked to find in part 2 is we're asked to find DC. So I'm going to highlight this in green here. So we need to find the line that's green there in the next question. So we're looking for DC, and if you look at the triangle DBC, so the triangle that is here, we don't have too much information. So what we might be able to do is use the other triangle to find out a few bits of information. So in this triangle that's in red, we know what 2 of the sides are, so we'll be able to work out the other side using Pythagoras' theorem. So Pythagoras' theorem, remember, c squared is equal to a squared plus b squared. So c squared being the hypotenuse, so the hypotenuse in that one is 6.53. We have a squared, which we can have as 5, and then I might label that side as x. So then we get 6.53 squared, which is going to give you 42.6409 is equal to 25 plus x squared. Take 25 from both sides, so you're going to get 17.6409 is equal to x squared. So then x is going to be equal to 4.2001, and I'm going to leave that x is going to be equal to 4.2. So here we now can say that this side here is 4.2. Again, the green triangle here is a right angle triangle because it has the right angle symbol. So what we'll be able to do in this case is we'll be able to figure out what the other side is using Pythagoras' theorem again. C squared is the longest side, so the hypotenuse, so I might call this y. So we have y squared is equal to the other 2 sides squared, so 10 squared plus 4.2 squared. So we're going to get y squared is equal to 117.64. So then to get y by itself, we get the square root of 117.64. When you put that into your calculator, you're going to get 10.846. We want it correct 2 decimal places, so we're going to get y is equal to 10.85. So that is DC corrected 2 decimal places, which is 10.85. So if we just highlight that there, so part II is 10.85. That's this question completely finished, and it also brings this video to an end. If you have any questions about anything here, just get in touch with me and I'll answer them for you. But I'm hoping that this makes using SOHCAHTOA or sine, cos and tan to find the length of a line much easier.